Okay, hopefully I'm live. I think so I'm live. I have to cross check just once and then I will start with vectors. Okay, yeah, I don't know why I am not live at Twitter. I do dual streaming basically, but okay, let me see if I'm actually live at Twitter or not. I should be uh, live at YouTube, but I'm not sure about Twitter. Let me once check. Okay, I can check it through probably Media Studio. Not sure. Okay. Okay, I have to do dual streaming in such a way so that okay, so I think yeah, I think I'm live. Yeah, I think I'm live at X Twitter too along with YouTube, so I can start studying now. Yeah. So basically, what's my goal uh, at this point of time? Okay, let me show you first. So in the evening session, we have to revise a bit of set, and what we can do next, set, and I have to revise vectors a bit, uh, and Trigno. Okay, I have physical book of Trigno, so uh, I won't be able to show it in the stream, but fine. Okay, then we have to finish vectors. Okay, I will finish vectors sessions in the night stream, uh, at night session when I study. I will try to do cover this thing and this thing right now. Okay, so let's first start by revising vectors. uh, Actually I did this till session 4, till vector components, so we can just go through this, and I'm planning to go through the problem set so that I can just solve it quickly. Yeah, that would be a better approach. Okay, let me once check that if I'm live at YouTube or not, because I haven't checked at YouTube, but I was just trusting my OBS that it will definitely uh, host me live at YouTube. All right. Okay, so can I just cross it? Yeah. Okay, I'm live everywhere. I'm actually live everywhere. No issues. Alright, alright. I just checked a lot, a bit a lot. So yeah, let's go with vector session 1. It was quite a long session. I will just go through this thing. So how we can find the magnitude, it's all about that. So how we how we will able to find the magnitude. So we can uh, just take the square and square plus it under root, we will get the magnitude. So in general, if these are the vectors, and if you want to find the magnitude, we will just take the square of each of the vector under root, we'll get the magnitude. And if you want to add it, we can add axis wise, like a1 b1 both are in the x-axis. We have to uh, add those, club those, and then if a2 b2 are in y-axis, we have to club these things, and same with a3 b3, we have to club these things. Okay, I mean, yeah, that's it in this thing. We can move ahead with problems. Okay, I have to zoom it a bit. Okay, river flows at this. So we what we have to do, um, I mean, we have to use Trigno here, I think. Yeah, we have to use the Trigno here. Uh, it is like AB cos theta, like kind of thing. I'll show you. I believe it's the same thing, yeah. So let's see it once. Okay, so this is the direction of river, this is the direction of boat. So it's basic Trigno question. So it's just applied physics in Trigno. There's nothing much we can do. And if we want to find the unit vector, so finding unit vector is quite interesting. Like we have to find a unit vectors in direction of 2 comma 3. So what we can do is, wait, let me open my notepad. Should I just solve this problem here? I will move this to my other screen. um, Hopefully it won't cause much problem, because I will just explain it, no issues. Okay, so I don't know why my pen tab isn't working. Okay, it's working now. So what we have unit vector. We have to find unit vector uh, of 2 comma 3. So for 2 comma 3, what we can do is, we can do this. It comes out to be 9 plus 4, 13 under root. Yeah. So for each unit it will be 2 by 13 and 3 by 13, so it will be a unit vector. So 2 by under root 13 and 3 by under root of 13, this will be a unit vector. Okay. So last question was to prove, yeah, last two questions are to prove that, like here, uh, diagonals of the parallelogram bisect each other. So we can do this by taking the diagonals. So it is quite possible too, but I don't want to jump into proof kind of question right now. So basically what we have to do in this, if I just think about it, then let's say uh, the parallel sides of the parallelogram are definitely equal, then we can expand that. So from that we get half of every uh, we can get a half of every uh, like segments, and then from there we have to show it in that way. Okay, I don't know why my mic is falling, so I have to fix it. I have a studio mic, so yeah, I'm just fixing its stand right now. Okay. Okay, we can move to the next segment, which is dot products. Okay, so in dot products there were not much of concepts. Yeah, there, there was this law of cosine, and that was it, I believe. There wasn't much of the stuffs to read. So I should write law of cosines here, because it helps. It will definitely help. uh, so what is law of cosines? So this equals to, uh, if we have to figure out the magnitude of c vector, then we can figure out it as magnitude of a vector square b vector square into cos theta no, not into cos theta, like minus of 2 cos theta. So it's like the basic algebraic formula, but we just have cos theta. So yeah, it's just like the main formula of the algebraic expression. Can I insert the screenshot here? Probably I can. Okay, I inserted the screenshot here, so it would be much easier to me to revise. Can I rename it as vectors? Okie dokie. Done. There wasn't much stuff to revise here. Let's just see problems and solutions. That's it. That's the main thing. I'm not into proof, so don't tell me to. So if you have to compute this, we can do this orally, mentally. I mean, so it's minus 12, uh, 2, 6, and minus 20. So it net would be minus 12, and it would be obtuse because I will show you guys one thing. So we have one rule: if it's negative, if a number is negative, then the angle would be like greater than 0. Let's say x, then the angle would be obtuse. So yeah, it would lie in the second quadrant, so it would be negative. So yeah, that would be obtuse. No issues. My mic just fall off. Okay, it was expected, honestly, but fine. But where do I keep my mic again? So that's the question. I don't think it will fall off from the place where I set it up, but no issues. I mean, everything happening in the stream itself. It never, like, I haven't used this setup in months, and everything was good. But when I tried something different, things got changed, which was, yeah, expected. Hopefully it's fine now. Yeah, so finally I'm back, and we can quickly go through the next things. So dot product. So yeah, we solved first question. Then we just have this second one. Uh, suppose also B suppose also B makes an angle 30 degree with A and B. A dot B equals to 6. Find A. Um, okay, we can do this. I have to revise a bit of Trigono, but it's quite possible to do this. Uh, let's say what we have and what we don't. Okay, so what we have is we have B, and B is 2 comma 2 comma 1, so this would be uh, 9 under root 9, and yeah, if under root 9, and we have AB, A dot B equals to 6. So what actually happens is A dot B should be equal to A B cos theta, right? So AB is this, we have B equals to under 9 under root 9, we have to find A, and cos theta is 30 degree, right? So so here what we can do, let's say angle is 30 degree, so 30 degree is pi by 6. Yeah, pi by 6. uh, so cos pi by 6 is under root 3 by 2. uh, if I'm not wrong, it's under root 3 by 2. Yeah, it's under root 3 by 2. I just checked from solution, it's 3 by 2. So under root 3 by 2. Acha, okay, so this thing will be 3 now. 3 into root 3 by 2, and if this is 6, then 2, so it would be 4 by root 3. So yeah, A should be, magnitude of A should be 4 by root 3. This would be answer. Okay, next question. What it is. So if A dot B equals to 0, what is the angle between A and B? So if A and B equals to 0, so we saw this in theory that it will be 90 degree. So 90 degrees, pi by 2. Yeah, so it would be pi by 2. I think we have to remember that. I will take a note of this term too. So from where we can take the screenshot, insert screenshot, screen clipping. So yeah, whenever I want to revise, I don't know what I did here. but we can delete this, I believe. Delete. Can I select this? Yeah. So we have dot product. Like it's almost same, but yeah, we can move ahead, I believe. So what's next? So uses of dot product, length and angles. Uh, it don't have much of the use, but okay, we'll study. Okay, so this is actually important. This is the same thing that I described in the solution, like just few moments ago. I did rough solution of this thing. So if 0 is bigger, then okay, I will just take a screenshot of that. So we have to remember this thing, that if it is uh, less than 0, if the value of this thing less than 0, then it would be obtuse. That's it. If you just remember one thing, then we can solve any question. And also this was in the last problem set. Okay, we can move ahead with problems and solutions. Alright, so what's the problem? Find the did we solve this? Find the angle between vector this and this. Okay, and what's the next problem? Take the points P, Q, R. For what values of P, Q, R is right angle? So if we want to make it right angle, we have to put it as 0. So for what value of A, it should be right angle. Um, okay, we can do this. Uh, I don't know this how to prove this, so I have to see the solution for this. But I can do both of them. I'm a bit confused in this one, but this is solvable. Two is solvable. I'm kinda confused in this. I mean, I know the formulas. We can just put it in the formula and solve this. So this could be a case. So here we have to find cos theta now. So what we can do is uh, okay, command A. Can I delete this? Yeah. Um, so what our formulas say is, sorry, can I select eraser pen? Yeah. So this is our formula: A dot B equals to AB cos theta. So if we have to find cos theta, then A dot B by AB, this should be it. um okay, so what are the values? A is I plus 8j, so 1 plus 8j. So 1 16. Okay, a equals to a equals to 1 comma 8, b equals to 1 1 comma 2. Okay, so 1 1 plus 16, so it will be 17 by AB. So, and 16, 8 into 8, 64. 65, this would be under root 65, and this would be 4, 5 under root 5, under root 5. So, under root of 65, under root of 5. So, this would be roughly answer. We can solve it further. Um, 13. So 65 comes 13. So 13 times 5 is 65. So we can write it as 5 under root 13 by 17. If I'm not wrong, I have to check once. Yeah. So cos of inverse of cos. Okay, we have to do this too. Okay, doable. This was doable. I don't know 3, so I have to see the answer for 3. So how it solved 2. So it just multiplied 2 with it, right? So P is this, Q is this, R is this. What is the value of A? A is PQ is right angle. So why it just took 2 pairs? Where is the third pair? Okay, let's see this once. I understood the solution of 2, but let me do this once. So let's say um, what I needed to understand was what we have to take. So PQ, QP and QR, we have to take this into account. QP and QR. Why? Because so this is the core thing. We can, well, everyone can do multiplication, but this is the core thing to understand. So if we have to take uh, from this, so we have to, so this is the angle that we have to uh, take into account. So for this angle we have to solve it via QP and QR. So what we can do, let's say just multiply QP first, Q and P. So it would be A. Wouldn't it be 0? Wait, let me just check once. Okay, I'm not sure why it want to be 0, because here if Q is this, P is this, and it turns out to this thing like A. So if we add this, it would be A, definitely A. If we add this and this, it should be 2, but it isn't. Okay, I don't understand what's happening here. Can we just ask AI what's and why it's happening? Okay, we just had to minus the thing. Okay, this is a direction, so P minus Q, R minus Q. Okay, okay, I need to take screenshot of this too. And take the dot product. Okay, I think AI explained it very clearly to me. So I will save this thing. It felt important to me. Like, it is just basic, but still important. So I can just write dot product. And also in the example of this, I can write QP. So this means this equals to Q minus P minus Q. So that was the core thing I was missing out. Okay, I can move ahead, I guess. And what's in this rhombus problem? So okay, so first we have to take uh, what we have to do. Maybe vectors this as shown in the figure. We have to have two diagonals. Plus p and a minus p we have. Okay, it just expanded the formula, and then we came to this as conclusion. Makes sense. Okay, last theory, last concept. Okay, it was basically how to take component. So here we can see how to take the component. So let a equal to this, b equal to this. You have to find component of both of them in different directions at first. Okay. Okay, so uh, it's very much doable. So if b is 3 comma 4, so 3 comma 4 means under root of 25, which is 5. um, this is rough, yeah. So we, in whichever direction we have to take the component, we can just like a in direction of b. If this is the case, then we can do a dot b by magnitude of b. So this is how we can find component in a direction of b. And in case of component b in direction of a, we can just do inverse b dot a by magnitude of a. So here we just have to put the values. So a is 10 under root 10, a is under root 10, b is 14, uh, 16, 9, 20, b is 25 under root 25, which is 5. Yeah, so we are done with everything then. So 5. Okay. Okay, so we can solve next problem. Oh, you guys won't be able to see the problems. um, I'll just put it here. So first question is this. Okay, I will just solve it. So this is the formula in through which we can just figure it out. So in first we have to in direction of b. So let's say here a equals to 1 comma 3. So 1 comma 3 means 9 10 under root 10 into b is b equal to 3 comma 4 25, which is 5. So 5 3 comma 4. Okay, we can also do we should not also we should do, this is under root 10, we have to remember that this is 5, um this is 1 comma 2, right? So we can write it as 1 comma 3, and then we just have to multiply it. So 3 plus 12 by 5, 15 by 5 equals to 3. That's the answer for the first one. Okay, next in we have the same numbers but in the direction of a, so we will just use this formula, b dot a by magnitude of a. So it would be b is 5, b is 3 comma 4, a is the same 1 comma 3, and magnitude of a is root 10, so 3, so 15 by under root 10, that would be the answer. Yeah, I just checked, it's correct. And the next question is, let's a is equals to this, b equals to this, find the component of a in the direction of b. Okay, we can do the same actually in this case too. So let's see if a equals to 3 comma 5 comma 7, b equals to 3 comma 4 comma 0, a direction of b, then we have to do this only. Then what we can do is first just multiply now. So 9, 3 into 3, 9, 9 plus 20, 9 plus 20 plus 0, 9 plus 29, so 29 by 16, 29 by 25. Is this the answer? Yeah, this is the answer. So 29 by 5 is the answer. So okay, why OBS is sending me messages? Have the stream crashed or what? Okay, it's encoding overload. I don't know why it's happening. No idea why it's happening. Okay, am I streaming for like 1 hour? Almost 1 hour. I just felt like it's been just a few minutes. Okay, we have completed our revision. No, last question is remaining. Last two questions are remaining, I guess. What are the questions? So let a equals to this, b equals to this, find the value of b. No, we just solved this. Which of the angle of for which angle theta the component of a is a direction of b equals to, so it will be 90 degrees, right? Pi by 2, it would be pi by 2. I mean, I just solve this two times, so I just learned that it's pi by 2. Let's see, it's pi by 2. Let's go. Okay, we completed this thing, division thing. So what we can do next, we can just move ahead with the next topic. Or do I have more things to revise? Okay, I just believe that this mathematics section is far much better, much easier to grasp as compared to maths for CS, or maybe maths for CS is boring at this point of time. uh, but it got better with sets, and I will also read determinants probability there, but okay. So areas and determinants, that's the next thing. How are the questions here? I haven't read, but I want to see the questions. How are the questions? So we have to compute this. So if I remember, we have to just cross multiply it plus it. So 4 minus 4 plus 6 10. Is it 10 base 10? Is it? Please tell me the solution. If it's 10, I will solve everything. So 4. Okay, we have to minus it. I messed up. I think I can solve the first three. Okay, let's just solve before actually going through the problem. Before actually going through lecture, let's solve the problems. Okay, so we have the determinant of 1 2 3 4. To solve this, is it like crisscross? 4 minus 6 minus 2. Am I right, or I did opposite? No, minus 2 is actually right. And then we have this thing. It is a bit on the negative side, but it would be it will be positive. It should be positive. 4 minus of it won't be positive, of 6, so it would be minus 2 again. Solving determinants are fun. Find the area of quadrilateral. Next we have to compute one more determinant, which is 3 4 1 2. So 6 minus 4, this will be 2. I don't know how to compute the area of quadrilateral here, so I will just see the answer. Yeah, every other answer of ours were correct. I have to see this. So after taking half, we just took the determinant of this. Okay, so uh, 3 and 8, it would be minus 5. So if we take mod of this, okay, we will have to study this thing. We can start. I guess I know basic determinant, but for area I need to study. Let's just go and study. Also, I think uh, if on weekends I get some time, I will study the basic mechanics. I want to study mechanics, like not in a very broad way, but in a very basic way, problem solving way. Uh, like only kinematics kind of thing. Kinematics and the oscillations. I like oscillations, so or even LNM, Newton's law of motion. We can just do that and uh, strengthen our mathematics. Okay, I don't think there's much to learn from here. This is just basic stuff. Okay, a dash equal to a dash is, yeah, the inverse of the main figure. Okay, got it. We actually have to study this. uh, Computation is easy, it's very doable, but other things. So yeah. Okay, I was just reading some stuff. uh and I'm back now. Okay, so we can solve this. 12 5, yeah, 12 minus 5 7. Compute the area of parallelogram here. So okay, what's the formula for area of parallelogram? Area of parallelogram formula. Don't mind me if I write wrong spellings. Okay, I don't know why it's not giving exact formula, but it's something half into base into height. It was like that only. So it's just base into height. Okay. The area is given by determinant of the vectors determining the parallelogram. Okay. So if these are the vectors, this is A, this is B, I believe we have to watch the video. Okay, it's just of 3 minutes.
Hello and welcome back to recitation. And I'd like to work this problem with you in which we're going to use determinants to compute the area of a parallelogram sitting in the plane. So why don't you take a moment to, why don't you take some time to work this out, and we'll check.
Wait a minute, if this is recitation video, then there should be the main video. Okay, here it is, the clip.
No. Okay, so let's move on to our next topic. So here we have found things, a triangle. So let's start with, a triangle in the plane. Now, the area of this triangle is going to be 1/2 of the base is going to be the length of A, and the height, well, if you call theta this angle, then this is length B sine theta. Now, that looks a lot like the formula we had there, except for one little catch. This is a sine instead of a cosine. How do we deal with that? Well, what we could do is first find the cosine of the angle. We know how to find the cosine of the angle using dot product. Then solve for sine using sine square plus cosine square equals 1. And then plug that back into here. Well, that works, but it's kind of a very complicated way of doing it. So there's an easier way. Okay, and that's going to be determinants. But let me explain how we get to that, maybe still doing elementary geometry and dot products first. So let's see. What we can do is, instead of finding the sine of theta, well, we're not good at finding sines of angles, but we are very good now at finding cosines of angles. So maybe we can find another angle whose cosine is the same as the sine of theta. Well, you've probably heard about complementary angles and how, if I take my vector A, I have my vector B here, I have an angle theta. Well, let's say that I rotate my vector A by 90 degrees to get a new vector A prime. Okay, so A prime is just A rotated by 90 degrees. Then the angle between these two guys, let's say theta prime, well, theta prime is 90 degrees, or pi over 2 radians, minus theta. So in particular, cosine of theta prime is equal to sine of theta. Okay. So in particular, that means that length A, length B, sine theta, which is what we would need to know in order to find the area of this triangle, is equal to, well, A and A prime have the same length. So let me replace that by length of A prime. Okay, I'm not changing anything. Length B cosine theta prime. And now let's say that we have A prime with this. And geometrically what it measures is the area. A and B are clockwise or counterclockwise from each other. I mean, the issue that we have, that's equal to the area of a parallelogram. So let me explain that again. So if I have two vectors A and B, so I can form a parallelogram with them, or I can form a triangle, okay? And so the area of a parallelogram is equal to length A length b sine theta is equal to the determinant of A and B, while the area of the triangle is 1/2 of that. And again, to be truthful, I should say these things can be positive or negative. So depending on whether you count the angle positively or negatively, you will get either the area or minus the area. The area is actually the absolute value of these quantities. Okay, is that clearer? Okay. Yes, sorry.
You said the determinant could be negative or positive. How do you fix it?
So if you want to compute the area, you will just take the absolute value of a determinant. Okay? So area will be well, I should say the area of a parallelogram so that it's completely clear. Sorry, do you have also a question? Length b sine theta. So 3 dimensions we are going to do now, okay? A, B, and C. And then the definition of their determinant is going to be, so the notation for that in terms of the components is the same as over there. This is A1 times the determinant of what I get by looking in this lower right corner. So the 2 by 2 determinant, B2, B3, C2, C3. Then I will subtract A2 times the determinant of B1, B3, C1, C3. And then I will add A3 times the determinant B1, B2, C1, C2. And each of these guys means, again, you take B2 times C3 minus C2 times B3. And this times that minus this times that, and so on. So in fact, there's a total of 6 terms in here. Okay, and maybe some of you have already seen a different formula for 3 by 3 determinants where you directly have the 6 terms. It's the same. Okay, it's the same definition. So how to remember the structure of this formula? Well, this is called an expansion according to the first row. So we're going to take the entries in the first row, A1, A2, A3, and for each of them, we get a term. Namely, we multiply it by a 2 by 2 determinant that we get by deleting the first row and the column where we are. Okay, so here, the coefficient next to A1 is, well, we delete this column and this row, and we're left with B2, B3, C2, C3. Next, the next one, we take A2, we delete the row that's in it and the column that it's in, and we're left with B1, B3, C1, C3. And similarly with A3, we take what remains, that's B1, B2, C1, C2. Finally, last but not least, there's a minus sign here for the second guy. Okay? So, well, it looks like a weird formula. Well, we delete this column and the column that it's in, and we're left with B1, B3, C1, C3. And similarly with A3, we take what remains, that's B1, B2, C1, C2. Finally, last but not least, there's a minus sign here for the second guy. Okay? So, well, it looks like a weird formula. And I mean, it is a little bit weird, but it's a formula that you should learn because it's really, really useful for a lot of things. So I should say, if this looks very artificial to you and you'd like to know more, there's more in the notes. So read the notes. They will tell you a bit more about what this means, where it comes from, and so on. If you want to know a lot more, then someday you should take 1806, linear algebra, where you will learn a lot more about determinants in n-dimensional space with n vectors. And there's a generalization of this in arbitrary dimensions. In this class, we'll only deal with 2 or 3 dimensions. Yes? Sorry, why is the negative there? Well, that's a very good question. It has to be there so that this will actually equal, well, what I'm going to say right now is that this will give us the volume of the box with sides A, B, C. And the formula just doesn't work if you don't put the negative. There's a more fundamental reason which has to do with orientation of space and the fact that if you switch 2 coordinates in space, then basically you change what's called the handedness of the coordinates. If you look at your right hand and your left hand, they are not actually the same. They are mirror images. And if you swap 2 coordinate axes, that's what you get. That's the fundamental reason for the minus. But again, I mean, we don't need to think too much about that. All we need in this class is the formula. Metrically, a box with as well, but then you have to be very careful with the sign factors. So I'll refer you to the notes for that. Okay, if you and by that I mean really in 3-dimensional space. Okay, this is something that's specific to 3-dimensional.
Okay, I thought that it won't be that long, but is it whole for the? I have to check it once. Like where this clip starts from. Yeah, I just watch session 6 too. So can I solve session 6 problems? I'm not sure what I'm doing, but yeah, I will just give it a try if I can understand it or not. Okay, so yeah, I can expand this. What does it say about the origin vectors? This, and this. Find the volume of the parallel piped with edges given by the origin vectors this. So if the volume is equals to just solving determinants this, is it possible? Let's just try, but first let's look here what we were missing. Because I think because of this only we went to that frame. Okay, probably the encoding is decent now. Yeah.
Sine of theta.
So, okay. Yeah, so how we can solve this problem? So compute the area of parallelogram. So the area is going to be determinant of the vectors determining the parallelogram. Okay, but there are 3 vector terms. So what we are gonna do? So how this got converted into 2 determinants? I have to see that. So 1, 3, 1, 3. and minus 2 comma 2. Okay, if we subtract this thing from this, it we will get these results. So from there we get the determinant, and if we get determinant we can easily calculate the values. So it's 2 minus 6, but it's 2 minus 6 minus 6, so it would be positive then 2 plus 6, that would be 8. Find the area of triangle with vertices this and this. Yeah, area of triangle is half times determinants, so 2 comma 2, let's say 2 minus of minus 6. So this would be 2, this would be around 2 6. Okay, I am a bit confused. I have to solve this so that I can get the clarity. Okay, so we have the determinant, 1 2 3 2. This is of minus sign, so we get 2 minus of, so minus 6, it would be, it should be this, right? So it should be this. I don't understand how it got to be. And even if after 8, then 1 by 2 of 8, it would be 4. I don't know where I am making mistake. Let me ask the AI. Yeah, I think I was right. It would be 4. Yeah, all good, all good then. Okay, I want to ask, I do have a confusion about how to select, yeah, what we can do with this figure. So let me ask this too. Okay, how to find the adjacent side vectors? Yeah, so it's the same thing that I wrote down in my notes. So if I want to find, like, this is P Q, okay, let me once find the adjacent side, or even if I'm wrong, I will just try to do it. So suppose we have to find QP. This is 1 comma O, and this is 2 comma 3. So it should be P minus Q, right? So 1 comma 3. Am I right? Am I right? Am I right? Yes, I am right. So it works. So whatever question you have, you should ask AI to clarify it. It will just give you a better view. So I think we are done with this session 5 problems. Okay, it's fine that we can solve this, but can we solve that bigger determinant, 3 by 3 cross 3 determinant? uh, let's once see if it's possible or not. Command A, delete. Okay, why it didn't got delete? Command A. Okay, so first we have to find the parallel pipe with the edges given by the origin vectors. So we have the origin vectors, we have to find the determinant. So what are the origin vectors here? So here we can see 1 2 4 2 0 0 1 5 2. This is the determinant, and if I try to expand it, then it would be 1 into so okay, this would be, this term would be 0, so it doesn't matter, minus 2 4 minus 0, then plus 4, ten minus 0. So this is coming out to be. So minus 8 plus 40, 32. If everything is right, it should be 32. Let me just check. I hope the formula is right. Yeah, it's 32. Boys and girls, we did correct calculation. It's 32. Now we have to solve next one. Okay, it's same. It is much easier, I would say. So let's try to solve this. So what's this? 1 2 3 4 5 6 7 8 9. So 1 into 45 minus 8 into 6, which is 48. Okay, minus of 2, 36 minus 42. So let's solve this first. So this comes out to be minus of 3 minus of 32, 6 minus 6 minus 12, so plus of 12, and then last one. So 3 32 minus 35, so minus 9. So this comes out to be 0, and yeah, we solved that. So we proved that this comes out to be 0, but what it actually says about the Schmidt vectors, let's see. Okay, so when the vectors are non-zero, then they are in 3D plane, and when the value it's 0, then it's not in a 3D plane, it's on a single plane. Okay, yeah, it is fine. So we can solve we solved session 5 and 6 right now. Let's jump to session 7, which is volume and elements in space. I don't know what kind of questions will lie here. Okay, I have to look on the charge too, because I'm running out of charge. Let's see which kind of problems are here. It's from session 6. Did I open session 6 again? I have to jump to session 7. Yeah, we are jumping into session 7, which is cross products. Cross product should be easy. So A cross B is the area of parallelogram. Yeah, so it was, yeah, height into base into height. So the action of A plus B is perpendicular to the plane of parallelogram with the right hand side rule. Okay, cross product is actually like easiest of the easy thing. Am I right, or I will just embarrass myself here? I compute this into this, or compute this into this. Wait, let me zoom it once. Okay, so we have to compute this cross this. So can we just normally cross it? So 2, negative 3 and 5. So 2 plus minus 1 plus 1, 5. It would be 4. Is it 4? Okay, I just crossed it. Okay, that's not how it works. That's not how it works. So what's actually the answer? Okay, if I see the solution once, I will get the concept, I believe. Okay, it's doable, but what's this? The area is A cross B, where A and B are vectors along with two adjacent edges of the parallelogram. Okay, let's find the adjacent edge, adjacent vector. So we just have to minus this from this. So 2, 3, 1, 2, 3, 1. No, so it's actually, yeah, 1, 1, 3, 1, 1, 3, 1. My bad. You have to just minus it. So it would be 2, 2 minus 1 and 5. Yeah, 2 minus 1 and 5. Okay, if we find this value and this value, what we have to do, so we can just do the cross product of these ones. So how we are actually doing it, we computed this cross product in problem 1a, we computed this in 1a, yeah, we computed this in 1a. So from here, for the area, we just have to find the magnitude, which is, we just have to square it and root it. Okay, no, I have to watch cross once, or read, at least just read the cross product, and I will just get the underlying concept. Where's, so A cross B, A I J K in, okay. So if we put it in the determinant form, then we just have to calculate the determinant. Yeah, the normal determinant. Okay. So here basically what we have to do, we just have to compute the 2 cross 2 vector. 4 minus 9. Yeah, it would be minus of 13. So magnitude of A cross B will be AB sine theta. Okay. The area of triangle. Okay, example, find the area of triangle shown here. So half of this area of triangle is a, can be find via cross product by just putting in the values. Okay, so can we solve these things now? Let me try it once. We have to compute this, so okay, we can compute. So suppose we have, not suppose, we actually have 1 3 1 2 minus 1 5 I j k. So these are our vectors. So let's take I 15 minus minus, it would be plus 1. So yeah, 16 I minus j. So j is 5 plus 1 6. So 5 plus 2, so 3 minus of 3j, and then we have plus k. We have k, right? Yeah, we have k. K is negative of 1 minus 6, so minus 7k. This is the value that we are getting, and if we have to compute for the next one, which is I plus 2j into 2I minus 3j, okay, let's say let's say 1 2 1 2 2 minus 3 0 0 I j k. This is our determinant for the next question. If we take I, it would be 0 minus of, yeah, it will be 0 I. For j, it would be 0 again. For k, it would be minus 3 minus of 4, so minus 7 k. Minus 7k. It was 7k, I guess. In the answer it was 7k. No, it was minus 7k only, so we reached the correct answer here. Minus 7k. Right, here's the last answer. Okay, last we have to find the area. Okay, let's find the area of the parallelogram. So first we have to have the adjacent sides, which is let's say, which we learned by AI, that if we have to find QP, then it should be P minus Q. Then it is P is 1 comma 2 comma 1, Q is 2 comma 5 comma 2. So we just have to subtract 1 comma 3 comma 1. This is our QP, and other adjacent side would be 2 comma minus 1 comma 5. Yeah, So this is the same vector that we solved here, right? 1 3 1 3 1 2 minus 1 5. So it comes out to be 16 minus 3 minus 7. So 16 3 7. So if we just square it, add it and root it, it would give us the magnitude. So for area we just have to find the magnitude. So magnitude equals to this. So 16 to 16 to 56 plus 9 plus 49. So to 49 plus 9 would be 58. 58 plus 56, 100, 108, 114. So 114 plus 200, so 314. So the it would be 314 under root. That is our answer. Okay, session 7 done. We can jump to session 8 now. Session 8 would be the last session of vectors part A. Let's go. We did it very quick. I mean, today it took me 3 hours to complete, but yesterday it took me 3 hours to complete 4 sessions, and we are already at session 8 today. Okay, this is actually, I feel that this is the right method to study. So okay, I'm not getting this. So it is basically about the triple products or what? There's just one problem question, just one. So find the equation of the plane containing 3 points, this and this. So if I just have to guess it, so it is just determinant. If it is just determinant, then we have to just solve it. Probably I have to watch the watch or just see the theory via okay. So we got our hand into equation of a on a equation of a plane. Okay, so this would be a last quick session. Let's see what we can do. So later we will return to the topic of planes in more detail. Here we will content ourselves with one example. Okay, find the equation of a plane containing 3 points, p1 this, p2 this, p3 this. So the vectors p1 p2 and p1 p3 are in a plane. Okay, so p2 minus p1, p2 minus p1 would be 0, 1 and minus 1, 0 1 minus 1. No, we are these are the values that we will have to minus from. So 0, minus 1 and 1. Yeah, 0 minus 1 1. And for p3 to p1, p3 to p1, so 1 0 2. Okay, we have this here, then we have to calculate determinant. So for I will take this minus 2 into 0, so minus 2. For j, 1, okay, 0, minus 1, minus 1. For k, it will be 0, no, it will be 1, minus 1, okay, 0, then minus of minus 1, it will be 1. So 2 1 1. What we have to do after that is orthogonal to the plane. Okay, now for any point p, xyz in a plane, the vector p1p is also in a plane, okay, and is therefore orthogonal to n, orthogonal to l. And okay, expressing with this with the dot product, we get n dot p1p n dot p1p, okay, equals to 0. Here we got n, this is our n, then if this is n, then p1p man, this thing is complicated here. Okay, n is the normal to the plane. I understood the whole thing till here, but what's the purpose of this? Okay, I really couldn't get the purpose of this. Okay, if we just have to put it in a xyz plane, so if x equal to this, y equal to this, z equals to this, that's it now. What's 2 doing here? Three one p1p. Let's ask AI. They are finding equation of a plane using a normal vector and a dot product, then simplifying into the familiar form. Oh, yes, okay. So what is going on conceptually? A plane in 3D can be described by a point on a plane, this normal vector n, okay, which is perpendicular to the plane. Here the normal vector n equals to minus 2 1 2. Yeah, that means any vector lying on the plane is orthogonal, dot product to 0 to n. Using a point on a plane, take a known point on a plane, call it p1 equals to this, any other point on a plane p xyz, the vector p1p equals to this, okay, lies in a plane, so it must be perpendicular to n. perpendicular to n in vector languages means this thing. Okay, so they write this into this, and using dot product computer dot term by term expand. So okay, I want to compute this by myself. So what's going on here? We have this thing, right? And we have x my p1, this is p1 p, which means p minus p1. So x minus 1, y minus 3, z minus 1. So if we have to take the dot product, x minus 1 plus it is 1, y minus 3 plus 1, 2 minus 1. Okay, so this would be minus 2x plus 2 plus y minus 3 plus z minus 1. Okay, so here what are the numerical values? Minus 2, 2. No, minus 2 is with x, so we don't consider this. 2 minus 3 minus 1, so plus 2 plus 2 minus 4 plus 2 minus 4 equals to minus 2. So after computing everything, we came to this conclusion that minus 2x plus y plus z minus 2. So it could be 2x plus y plus z equals to 2. This is z. Okay, we came to this conclusion. I think the AI explained it really well. I will just copy these text and place it in the vector. Okay, I should create a new page named planes, and I can paste it. Okay, can I just take the screenshot of this thing? Yeah, that would be great. All right then. I think I've completed uh, the uh, the problem statement. The problem set would be is almost same, uh, like this. We just have to change the just different values, same question. So we'll solve while revising it. Okay, I think we have completed part A, which is determinant planes. Then I have to do matrices and system of equations, which is it lengthy? It isn't lengthy. 1, 2, 3, 4, 5, 6, or 6, 7 lectures. 6 lectures. Okay, we will do that. So we have to uh, read equation of planes one more time, which will be in depth. Yeah, it it would be on depth. It would be on in depth. So that would be interesting. And I am just debating about should I just go through this or not, because it is more on the physics side. Okay, I will just do it. Okay, so I think I've completed my goals of for today. Mm, this is done. This is done. We finished 4 sessions. At least 1 unit. Uh, I will try to do it at night. Uh, okay, I have to revise two sessions for sets and uh, predicate propositions kind of things. These were two important sessions that I have to revise at the night session. I did this major thing. Uh, okay, okay, I will keep it to that only. Alright, I will close the stream for now.